Picture this, it is Friday afternoon, Sarah ships a big nightly load. The job crashes halfway through and her morning dashboard reads half-written garbage. Here is the problem, plain files sitting on a data lake have no transactions, no schema rules, no undo button. The storage just holds bytes. It has no idea those files are supposed to be one clean table. Delta Lake fixes all three. It adds transaction, schema enforcement and time travel on top of the same cheap storage you already pay for. Let me show you exactly how it pulls that off. Take a look at what plain parquet on a lake really gives you. First, no acid, a job that dies mid-write leaves partial files sitting right there, and your readers can see them. Second, no schema enforcement. Someone writes a string where a number belongs and the table quietly corrupts. Nobody gets an error. Third, no history, overwrite the data and yesterday is gone forever. The core issue is simple. These are just files. The storage layer does not know they form a table. That one gap causes every pain you have ever felt on a lake. So how does Delta close that gap? Your data still lives as plain Parquet files. Nothing exotic there. But Delta adds one extra folder beside them called the Delta log. Every single change appends a small JSON commit. That commit records exactly which files were added and which were removed. Now the magic part. Readers do not trust the raw file listing in storage. They replay the log instead, and the log tells them the precise set of files that make up the table right now. The log is the source of truth, remember that line. It explains everything that follows. We just met the log. Now here is the mental model that makes it click. The transaction log works like Git for your table. Each commit is immutable. Just like a Git commit, you never edit the past, you only append. The current table is the log, replayed up to the latest version. Think of that as Git head. And because the full history stays around, you can check out an older version anytime you want. That is time travel. If you understand Git, you already understand Delta. Same idea, applied to your data. Let me show you how ACID actually happens. Step by step, a write first stages brand new Parquet files, but those files are invisible. Nobody can read them yet. Then it commits exactly one log entry. That single commit flips all the new files visible at once. All or nothing. Now watch the failure case. If the job dies before that commit lands, the stage files just sit there unseen. Readers never know they existed. And concurrent writers get checked at commit time. So they cannot silently clobber each other. Visibility flips on the commit, never on the file write itself. Now, let us talk about the schema. Because this is where lakes turn into swamps. Delta gives you two behaviors. First, enforcement. A write with the wrong types or surprise extra columns gets rejected outright, not silently loaded, rejected. Second, evolution. When you actually mean to add a new column, you opt in with merge schema. So accidents are blocked, but intentional changes are easy. The result, your table stops drifting into a swamp. The schema becomes a contract that storage enforces for you. Your future self will thank you for this. Let us create a real delta table. There are two ways and they end up identical. In SQL, you write create table orders with ID, amount and order date, then using delta. That using delta clause is the whole trick. In PSpark, you take a data frame and call write format, delta mode overwrite, save as table orders. Same outcome, different door. And here is the part people miss. It is still Parquet underneath. Using delta does not change your file format. It just adds the transaction log on top. That is the entire upgrade. Morning. Now meet the command that lakes never had. Merge, you write merge into orders using your updates matching on the ID when matched, update the row when not matched, insert it. That is the full change data capture pattern in one atomic statement. Insert or update decided per row committed all at once. Now think about how you did this on plain Parquet. You rewrote whole folders by hand and you prayed nothing crashed in the middle. Merge takes that entire fragile ritual and turns it into one safe line. Here is the feature that saves careers. Time travel. You can write select star from orders version as of 3. That hands you the table exactly as it stood at commit 3. Prefer a moment in time, write timestamp as of a date and delta finds the right version. And when a bad load lands, you do not panic. You run restore table orders to version as of 3. One command and yesterday is back. The log kept every version, so undo is always on the table, literally. So why is delta also fast? Let me show you the first reason. The log stores min and max statistics for every data file. Per column, say you filter on order date. Delta checks those ranges first. It reads only the files whose range could possibly match your filter. Everything else gets skipped without ever being opened. Think of a bookshelf organized by genre. You skip whole shelves instead of scanning every book. On screen, a query touches just 2 files out of 10. The other 8 are skipped because the stats live right there in the log. Data skipping works best when your files are well organized. That is what these two commands do. First, optimize orders. It compacts many small files into fewer big ones. Fewer files means less overhead per query. Second, optimize orders Z order by customer ID. Z order collocates related rows together, so even more files get skipped. When does Z order pay off? When you filter on a high cardinality column, like a customer ID or an order ID. Optimize fixes file size, Z order fixes layout. Together they make your reads fly. Let me paint the small file problem in one picture. Streaming jobs and frequent appends create thousands of tiny files. And each tiny file carries a cost, more metadata to read, more open and close work for every single query. Your engine spends its time on bookkeeping instead of real work. On the left, a dense grid of tiny squares, slow and red. On the right, after optimize a few large balanced files, fast and green. Compaction merges the mess. Fewer right-sized files mean every read does actual work. That is the whole game. Now, let me warn you about the most common delta mistake. I see the wrong pattern. A streaming or microbatch job appends forever and optimize never runs. Not once. Why does it break? Queries start to crawl, reading millions of tiny files, and the transaction log itself bloats with every append. The right way is simple: schedule, optimize, and Z order to run regularly or turn on auto compaction so Delta handles it for you. The engine will keep your table fast, but only if you let it do maintenance. Let us talk operations, starting with cleanup. Here is something that surprises people. Old files that no version needs still sit in storage. Delta does not delete them automatically. That is on purpose to protect time travel. When you are ready, you run vacuum orders, retain 168 hours. That deletes files older than your retention window, which is 7 days here. The rule of thumb: run optimize. Then vacuum on a schedule, compact first, then reclaim the space. That order matters, so keep it in your head. Every production choice here is a trade-off. Let me make the triangle explicit. Keep more history and you get more time travel and more safety, but you pay storage for all those old files. Run Z order and optimize and your reads get faster. But each run spends compute upfront. You cannot max all three corners for free. So here is the rule: I live by longer retention for your critical tables, and optimize and Z order only the tables you actually query hard. Tune per table, never globally. Your bill and your users both win. Before you optimize or roll back anything, you need to see inside the table. Two commands do that. First, describe history orders. It shows every version, who changed it, what operation ran, and when. Second, describe detail orders. It gives you file count and total size. That is your small file scorecard right there. Together, these two answer the only question that matters: should I optimize, should I vacuum, or should I roll back? When in doubt, describe first, then act. Let us tie it all together with a real daily pipeline. Each morning you land the day's file as delta and merge today's changes into the orders table. One atomic commit, dashboard stays correct. Then nightly maintenance runs. Optimize Z order by customer ID, followed by vacuum, retain 168 hours. Compact, then reclaim and the safety net. If a bad file ever lands, you restore table orders to version as of the last good version. Load by day, maintain by night, recover in seconds. That is a production delta pipeline in one breath. Step back with me for a second. Notice that every feature we covered falls out of one mechanism. Acid and clean failures, that is the commit being atomic, visibility flips on the log, time travel and rollback. The log remembers which files made each version and speed. The logs per file stats power data, skipping and optimize compacts those files down. One transaction log, every single feature traces back to it. Once you see that, Delta stops feeling like a bag of tricks. It is one elegant idea. Here is your Delta cheat sheet. Screenshot this one. To adopt, use using Delta or format Delta. To upsert, use merge into to evolve. Use merge schema for speed, run optimize and Z order by. To recover, use version as of or restore. To clean up, use vacuum. And to inspect, run describe history and describe detail. That is the entire working vocabulary of Delta Lake in 4 boxes. Pin it next to your desk. You will reach for these commands every week you work on a lakehouse. Now, here is what we proved today. One idea, the transaction log turns a plain folder of files into a real table. Acid, schema, time travel, merge, data skipping, all of it from that single log. If you want to build the full lakehouse hands-on, the Databricks complete platform course is linked below. And subscribe for the next ones, where we go deep on pipelines, streaming and cost. One honest question before you go. Are you still running on plain Parquet? Tell me why in the comments. I read everyone.